All right, folks, we are doing question 14 on the summer assignment. So here's the deal. I think this is a really lovely time for a tree. I would like to talk to you about what trees are good for. So the idea here is that we have two separate events, women or men, and whether they made their bed or didn't. And the reason I think this is fantastic for a tree, much better than heads or tails for coins, is that the probabilities are unequal in each path, and so this is a way to kind of sort all of that. So anytime a tree splits, these two events are mutually exclusive. You can't be both of these in this situation. And they always add up to one, so they're complements if there's two of them. So for the women, once we know the chance of being female over here, when you split it into made the bed or didn't, these two have to add up to one. These are mutually exclusive. You can't be both of these at the same time. All right. And then the other idea is, so if things are mutually exclusive, you could freely add them. The other idea is that, and this is kind of weird visually, but the other idea is that if you're going along the tree, you're multiplying the chance of each event to kind of look at the compound event of doing both, right? So the chance of being a woman and making your bed is just 52% and 72, which we're going to multiply, right? So it's a chance of being both events at once. That's going to be a multiply. So chance of being female and not making your bed, that's the and right here, is 52% chance of being female times 28% chance of a female making their bed, 0.146. Technically, what the second event is the chance of making a bed given that you're female, because that's different than what it is down here. Same thing for the men. So chance of being a man who didn't make his bed, 48% man, 54% didn't. And multiply those two. Now, a couple things logically about the setup. All of these black probabilities should add up to 1. There's nothing else that's possible. And then the other thing I want to say is if you split this, right, if you add these two up, you need it to add up to the chance of being female. I think we're good. Same thing down here. Right? These should add up to the chance of being male. So we're kind of splitting the chance of being male into two separate ways of doing that. Okay, so to answer the questions, the question says, find the following. The percentage of all adults who are men and make their beds. So I got all this already, right? So the thing I love about organizing a sample space is once it's organized, you're ready to answer whatever question. It's going to take no time. So the chance of being male and making your bed, I have it. It's this way, 0.221, and I showed the work above. Then, that's A. Similarly for B, chance of being women and making your bed. That's the upper path. So I have that. That's 0.374. The percent of all adults who make their beds is going to be these two together because there's no other ways to make that happen. Right? So the chance of making your bed is going to be the chance of being male and making your bed, and the chance of being female and making your bed. And again, we don't really have other options available in this problem. So we have 0.221 plus 0.374. What I like about this problem is it's really walking me through the logic of how to look at trees, what information trees are giving you that is helpful, and how to answer the question on the bottom, which is a very common question. Right. So I've got 0.595 is the chance of making your bed. All right, now here comes the final question. If a person has made their bed, what's the chance that that person is a woman? So the way we do this, we say, what's the chance of being female given that you've made, that's not female, given that you've made your bed? The formula she says, the way you do this is, I don't like using this one, but I'm just going to offer it. It's available. The chance of being female and making your bed divided by the thing that was given, that's definitely true, which is you make your bed. So you can see that we have both of these numbers available already. And the idea here is that if you look at the table, the chance of making your bed is you either went this way and got this number, or you went this way and got this number, and then we add these two, and these two other events are out, right? So we have the chance of making your bed is 0.595, and the chance of being female and making your bed is 0.374. We're ignoring the women who didn't make their bed because that doesn't apply in this situation. If you knew for sure somebody made their bed, then the women who didn't don't qualify. And then heads up, guys, as far as numbers go, I accept fractions and I accept decimals. I don't accept decimals on top of each other in a fraction. So this needs to continue. Okay. So if somebody has made their bed, the chance that they are female is 63%. This is interesting because 72% of women make their bed. This is lower than that. It's kind of like a weird averaging of the two chances of making your bed. All right. So this is a very, very common thing. If you ever see a question that's a probability question that's asking you about like vaccinations or new medical stuff, this is a really good option.